Earth Science Summer Project, Soil Contamination, presented by Amy Mendez. Why did I select this topic? The recent extreme weather precipitation events we experienced in Texas in May and June got me thinking about how urban runoff affects the soil after flooding. We've all seen the parking lots at H-E-B with packed cars, and when we're not packed, you can see the oil that has seeped from the engines to the pavement. The same thing applies to residential driveways. You notice right away when there's an oil leak because driveways are usually a lighter color than street pavement. Where does it go? Does it end up in the soil, in the water? Does it affect wildlife? Does it affect natural water resources like ponds, lakes, and aquifers? What about the nearby agriculture? There's so many questions that I was thinking about. Of course, I had to narrow it down to just one. I chose soil. Background research. So I found two articles that I'm going to reference, and these kind of help me narrow in on the soil topic specifically. So the first one is Crude Oil Hydrocarbon Bioremediation and Soil Ecotoxicity Assessment. And what I took from there was the effects of the hydrocarbon bioremediation on soil toxicity was investigated in two soils with high and low toxicity levels found. The other article is Urban Runoff as a Source of Polycyclic Aromatic Hydrocarbons to Coastal Waters. And what I extracted from that article was the loads of polycyclic aromatic hydrocarbons in urban runoff were higher at a highway and industrial land uses in comparison to the commercial and residential areas. And right there, that piece really solidified how I determined my site locations. So both of these articles benefited me in my research. So brainstorming about the problem. I came up with the 3 questions during my brainstorming that kind of got my creativity flowing and investigative journalism abilities ticking. So my first one was, after an extreme weather event, the visible oil contamination of paved areas doesn't only get washed down storm drains. Do the chemicals in the oil also get washed into the surrounding soil? Are the chemicals present in the surrounding soil of both high traffic and low traffic paved areas? Is there a difference in fuel chemical runoff found in soil from the metropolitan areas versus the rural areas? All of these questions came up during my brainstorming process. What is a hydrocarbon? Or a polycyclic aromatic hydrocarbon, to be more precise. So poly means many, and cyclic means circle, so they're like many circles, made up of only hydrocarbons, which are hydrogen and carbon. Common sources of PAHs are like fuel exhaust, plastic, cigarette smoke, and automobile engine oil. And something that most of us are familiar with is that in cities, human activities have enriched the upper soil layers with hydrocarbons as well as the atmosphere during the last centuries. Problem statement. Often after severe weather events such as extreme flooding, urban runoff can lead to auto oil contamination of the surrounding environment. It is important to determine which aspects of the natural environment are affected by this type of chemical contamination, and to what extent. Questions of inquiry. Number 1. Are auto oil contaminants present in soil collected? Number 2. Is there a difference in contamination incidence in metropolitan areas versus rural areas? And number 3. Within metropolitan and rural areas respectively, is there a difference in contamination incidence when different locations are compared based on proximity to oil contamination sources? Hypothesis. Metropolitan locations contain a greater incidence of hydrocarbon soil contamination when compared to rural locations. Materials and methods. So as you can see from these 2 pictures, I repurposed a drink container from Chick-fil-A to be precise, because those are really strong. So I felt really good about it when I was out in the field doing my sample collecting. Here you can see the list of materials. There's 12 different things that I used to conduct the experiment. Experimental methods. So the process, I tried to make a quantifiable intensity table because the test strips that I ordered didn't come with a quantifiable scale. So I devised my own. It's kind of similar to the pH scales or strips that we used recently in a lab. So the intensity scale, I assigned a number to the blue intensity of the color. Again, because the new pig test strips didn't come with an intensity scale already. Purpose: to generate 3 different sets of soil samples containing increasing amounts of high-tech 3 HD-30 oil in order to use a scale of measurement for my experimental soil collection. The goal was to make a numerical gradient scale where a number from 0 to 6 was assigned to each of the 6 soil samples, assuming that they had variations in blue color. So there was a process of steps I went through. I set up 3 sets of 6 cups, each containing 1 cup of organic soil. I added increasing amounts to the soil, each soil sample, and I placed an oil test strip in each of the soil samples for about 4 hours at room temperature. And then afterwards I came back and I checked the color change in intensity on the strip. And then I recorded the data in tabular form. Determination of qualitative scale. So after testing the strips to determine a gradient scale, I found that there was no gradient observable. So the test strips were only intended to test for basically the presence or absence of hydrocarbons. So this experiment showed that the method that I wanted to use couldn't be used to measure a quote-unquote amount of hydrocarbons. So I decided to either use either a yes or no data collection and data reporting system. So for the sample collection cities, I researched the population and precipitation level for various Texas cities. So I went through like a lot of them, like Schertz and Hondo and Castroville, but I was looking for a large, a large range from either high to low. So San Antonio, we got a lot of rain, and I wanted to compare that to some place with same metropolitan and rural areas, but that they got less rain than we did. So with these sample collection sites, I kind of wanted them to be different in that one of the cities had, a lot of rain as compared to another city that had a higher than normal amount of rain, but it was still significantly less than what San Antonio had with the extreme weather event in May and June. I chose McAllen. And I defined specific data collection sites within those cities based on the high-low population areas and proximity to the fuel runoff sources. So in each of the cities, I chose a metro HEB, a metro gas station, and a metro residence. And then I also chose a rural HEB, a rural gas station, and a rural residence to compare both data. Hydrocarbon detection method. So in reading over some of the research papers, I wondered how exactly they were testing for hydrocarbons in the field. It kind of has to be portable. So like after an oil spill, the EPA employees that are sent out have to be able to test the water and the soil, and it has to be portable. So I came across this testing method, which was also within my price range. For about $65, I had one expressed to me to conduct the soil testing. It's called oil detection test paper. So in liquids or soil, the detecting strips show the presence of hydrocarbons by changing color. In this test strips, the color changes to blue. This is my predicted data based on my research, which in the outcome was not completely accurate. But that's what science is, right? So I thought that all of the metro locations in San Antonio and in McAllen would test positive for hydrocarbons in the soil. But based on my experimental data, it was incorrect. So here's my experimental data. A1 is McAllen, and out of all of the 6 locations, only 2 of the metro locations tested positive for hydrocarbons. It was the Metro HEB and Metro gas station in McAllen. as compared to San Antonio, where our Metro HEB, Metro gas station, rural HEB, and rural gas station all tested positive for hydrocarbon presence. So the number of hydrocarbon incidences present and absent were dramatically different than what I predicted. And now for some data analysis. Overall incidence of hydrocarbon presence or absence within all 12 sites combined. I predicted that there would be more sites with hydrocarbons present than absent, but actually the data shows otherwise. So in this slide, I wanted to know the overall hydrocarbon incidence in San Antonio versus McAllen, Texas. And, you know, with what I predicted was that San Antonio would have a greater overall hydrocarbon incidence, and the data agreed with my prediction. Here, delving into the data a little bit more, looking at the hydrocarbon incidence at metropolitan versus rural sites for San Antonio and McAllen, I predicted that the metropolitan collection sites had an overall higher hydrocarbon incidence as compared to the rural collection sites, and the data shows that to be my prediction to be correct. Here, the metropolitan versus rural hydrocarbon incidence in San Antonio, Texas. My prediction was that the metropolitan sites would be greater than the rural sites, and our data shows that there is just as much hydrocarbon incidence in the metro San Antonio versus the rural San Antonio. Metropolitan versus rural hydrocarbon incidence in McAllen, Texas. So the prediction was that the metropolitan sites would show an equal hydrocarbon incidence as the rural sites. My data showed that there is a greater hydrocarbon incidence in Metro McAllen than in rural McAllen. Hydrocarbon incidence at rural sites from San Antonio, Texas versus McAllen, Texas. So here, I predicted that rural sites from both cities would have the same number of hydrocarbon incidents because both contained a high traffic HEB and a gas station. However, the data showed me that rural McAllen collection sites had 0 hydrocarbon incidents when compared to the 2 San Antonio sites. Hydrocarbon incidents at metropolitan sites from San Antonio versus McAllen. So I predicted that the metro sites from both cities would have the same number of hydrocarbon incidents because these are both heavily populated areas and being the metropolitan collection sites. And my data proved my prediction to be true, showing that the metropolitan sites in both cities have an equal number of hydrocarbon incidents. Conclusion: San Antonio had a higher number of hydrocarbon incidences as predicted. McAllen's metro sample collection sites had a lower number of hydrocarbon incidences than predicted, and rural San Antonio had the same number of hydrocarbon incidences as metro San Antonio, as predicted. An extreme weather event like the ones we recently experienced in Texas can cause problems months after in nature. In urban runoff, the presence of hydrocarbon can be detected in the soil. Based on the research, I hypothesized that I would be able to detect the hydrocarbons in the soil I collected. The purpose of this project was to test this hypothesis by collecting soil samples from a high population, high precipitation location and a low population, low precipitation city, and the testing for them for the hydrocarbon presence or absence. Pitfalls and future goals. I wish I had more time to work on the project. Budget, I spent probably more money than I really wanted to. And scope, more samples at each of the locations would improve an experiment like this. And also confirming a gradient scale already exists with any testing supplies. Thank you for your time and for watching my video presentation of detecting hydrocarbons in soil from urban runoff.